Hello everyone, this is a snapshot recording on Set Basics. You should be familiar with the following concepts from either the lecture or from your readings. This essentially covers sections 2.1 and 2.2. Now, you should always try working the examples prior to watching the video. That is, stop the video, try the problem, play the video, and then keep repeating that process. True-false type problems. Here we're being tested on understanding the concepts on the previous page. So again, it's expected that you have at least read over the course material and or listened to the lecture. So we're going to walk through each one of these. I suggest that you stop, pause, play, that sort of thing. 0 is an element of the empty set. This is false. And the reason it is false is because the empty set contains nothing. Nothing at all. 0 and the empty set really have nothing in common to one another. B. This is a set in set builder notation. An element of the set satisfies these two conditions. It has to be a number less than 4, and it also has to be greater than 8. I know of no such number that is less than 4 and at the same time it is greater than 8. If this was OR, then there'd be a lot of numbers. So yes, this is the empty set. This is true. C. Is the element on the right-hand side a member of this set? That is what this notation here is. That notation represents element. So is the thing on the left inside the set on the right-hand side? And the answer to that is false. It is not the case. 18 is a member of this set because 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. But the item on the element on the left-hand side is a set that contains 18. So that is why this is false. D. If two sets are equal, they have to be equivalent. This is true. The reason why? If they're equal, they have the same elements. Well, if they have the same elements, it's obvious they must have the same number of elements, and that's the definition of equivalent. So, equal sets are equivalent. E. Are these two sets equal? Well, the set on the left has an 11, set on the right has 11. Set on the left has a 4, set on the right has a 4. Set on the left has a 17, the one on the right has 17. Both these sets contain the same elements. Order does not make a difference, so this is true. F. Is the set on the left-hand side a proper subset of the set on the right-hand side? Proper subset requires it to be a subset. Well, that's not the case, because here's an element on the left-hand side that is not contained on the right-hand side. So we're not even a subset, let alone being a smaller set. So this one's false. The last one. Is this a proper subset of this? In order for it to be proper, any element in here, well, there's a 3, that element has to be on the right-hand side. Well, similar to the problem above, it's tricky. 3 is not an element of this set. A set that contains 3 is an element of this set. So, these two sets are different. This one has an element which is not contained in the set on the right. So this one's false. Okay, again, hopefully you're stopping and you're pausing. Number 2, is this collection a set? And if so, list the members. X is such that X is one of the 5 most ugliest dogs. Well, the word ugly here is a problem because what one person means by ugly would be totally possibly different than someone else's interpretation. That is, this collection is not well defined. It is not well defined. In other words, this adjective ugliest needs to be defined in order for us to be specific in terms of what is a member of the set or not. So it is not well defined. Number 3, the cardinality of the empty set. Cardinality means how many elements are in the set. The number of elements in the empty set is 0. So the cardinality is 0. Number 4, how are the following related? So if you look at the 2 items on the left and right, how would you interpret them in terms of being having some sort of relationship? If you look at problem A, the elements on the left-hand side are elements on the right-hand side. So we know this is at least a subset. Now, if you notice, the set on the right-hand side contains elements not in the set on the left-hand side. So it's actually a proper subset. So the stronger statement is proper. It is a proper subset. B, on the left-hand side, we have the empty set. On the right-hand side, we have a set containing 3 elements. The empty set is always a subset of any other set. The empty set is always a subset, but again, we could actually make this a stronger statement. I just wiped out the screen, sorry. But again, this could be a stronger statement, and that stronger statement is it's a proper subset. C, the empty set is a number divisible by 9 but not by 3. Oh, this is equal to this because the set over here does not contain any elements. There is no such number divisible by 9 but not by 3, because if it's divisible by 9, 3 divides 9. So these 2 things are equal. So up here, I'll just put this back in. No, not well defined. Okay? And this one here, the cardinality, 0. All right, anyway, hopefully I don't do that again. Oh, this here is a proper subset. All right, I'll mess up. You're going to see it. Okay, number 5. Calculate the number of subsets and the number of proper subsets for the sets. When you have a set, the number of subsets is 2 to the n, where n is the cardinality of the set. The number of proper subsets, well, you have 2 to the n subsets, but there's only one subset that is not proper, and that is the set itself. So if you wanted proper subsets, all you have to do is subtract 1. So for A, we have 3 elements, so it's 2 to the 3rd power. So we have 8 subsets. The number of proper subsets would be 1 less, because again, the only subset that's not proper is the set itself, because it's not missing anything. So it would be 7. For B, X is such that X is a state in the United States. Again, there are 50 elements in this set, so the number of subsets is 2 to the 50th. Well, that's a big number, so we're going to leave it like that. Proper subsets, 2 to the 50th minus 1. The one set that is not proper, and that is the set itself. Number 6. Are these true or false? The first one, it is saying the empty set is a subset of the empty set. The empty set is a subset of every set. The empty set is a subset of every set. B, is the empty set a proper subset? Well, this one's going to be false, because if you're going to be proper, there needs to be something over here that is not over there. That's not the case for the empty set. So the empty set is always a subset, but if it's going to be a proper subset, there's going to have to be something in the other set itself. Number 7, I give you two sets A, B, and I want to know how they're related. Well, how are they related? They're not equal, because A contains a 3, B does not. A has a 3 in it, B doesn't have a 3. B has a 4 in it, A doesn't have a 4. So neither one subsets of one another. The only thing I can really say is they have the same number of elements. So the only thing I can say is that they are equivalent. They're equivalent because they have the same number of elements, but there's no other relationship going on. Problem number 8. Again, stop the video and give this a try. If you have exactly 1 nickel, 1 dime, 1 quarter, and 1/2 dollar, how many different possible amounts of money can you lend to somebody? The hint here is to think subsets, because I can look at this problem as a set. I have a nickel, I have a dime, I have a quarter, and I have a $1/2 dollar. When I want to lend somebody some money, I am going to have to pick from one of these. I am going to have to select elements from this set. When you are selecting elements from a set, you are forming subsets. Well, when you form subsets, you know how many possible subsets there are, and that is 2 to the n. In this case, n is equal to 4, so 2 to the 4th is 16. There are 16 possible ways of lending somebody money. Now, the empty set would represent the scenario where I choose not to lend them anything, right? So think about this problem again. It's a very common type problem on a final exam, so think about it. I believe this is it, and so hopefully I've gotten through my first snapshot, which there are more to come. Thank you very much.